Hi everyone, hope you're doing okay. Today we are going to be looking at section 5.6, the law of sines. We are going to be looking at some specific cases of the law of sines. In the second video we're going to be looking at finding the area of a triangle using the law of sines. And later this week we're going to be looking at some ambiguous cases that come up with the law of sines. So at any point if we're going too fast, feel free to pause the video and write what you need to get down or replay it at your own pace. We need to remember some of our concepts from geometry. How do we prove that triangles are congruent? Well, if we have a right triangle, we can use our hypotenuse leg. But what if we don't have a right triangle? If we have a right triangle, then we can also use some trig. But we can prove triangles are congruent by hypotenuse leg. If we do not, we are going to be looking at either an angle-side angle, where the included side is congruent, we can be looking at an angle-angle side, where we have two angles in a row and then the side. We could have side angle side, so an included angle is congruent as opposed to the included side being congruent in the first example. Or we could have side, side, side. In geometry we found out that angle, angle, angle does not prove triangles are congruent, so we're really looking through one of this list. These theorems ensure that triangles exist if we are given the information for these pieces. So if we are given information of a triangle and it tells us the angle, then the included side, and then another angle, a triangle will exist. If we're given two angles and then the next side, a triangle will exist. If we have side angle side, we're going to have a couple different things come up, and those are the ones that we're going to be looking at tomorrow. So we do not have to have right triangles, and then we're going to use the law of sines to determine the missing parts. So what is the law of sines? When we were reviewing our trig, someone put this on the board. So we have the sine of angle A over little a equals to the sine of angle B over little b equals the sine of angle C over little c. Those are each three ratios, and where those relationships come from are looking at the large letters. Those are always our points, and for our triangle those are our vertices. The little letters are the side opposite that, so it is the amount or the length of space that our given angle A is going to take up. So we've got one pair here. Oops. We've got another pair here. And we've got a third pair here. And if we're taking a look at those, each one of those is going to be a little bit different because they're taking up a different amount because of the angle. So if it was a really skinny angle, the opposite side would also have to be pretty skinny. If it was a larger angle, like angle B, it's going to take up more space. So the opposite side is going to be larger. That's where those ratios are coming from. And we're going to use that to solve for a triangle. If we're asked to solve for a triangle, that means we need to find all of the missing angles and all of the missing sides that we don't have. So the first thing I'm going to do is I've got an information. I'm going to draw a picture. When in doubt, sketch it out. Doesn't have to be accurate. So let's make this angle A, angle B. Our leftover is angle C. Angle A is 37 degrees. Angle B is 72 degrees. And side A, so opposite angle A, is 11. So we have three things that we need to figure out. We need to find the measure of angle C. we need to find side B, and we need to find side C. We're going to use approximates, so we're going to make those squigglies. All right, so let's see what triangle congruence we have here. We're given an angle, and then a side. So angle, angle, side, that will give me one unique triangle, and this is it. So we need to figure out our missing information. So we're going to use the triangle sum theorem, that all the angles of a triangle have to add up to 180 degrees. So we've got 180 degrees, A is 37, B is 72, and our leftover is C. So when we're solving for C, we're going to subtract 37 and subtract 72, and angle C is 71 degrees. We need to figure out side B. So side B is down here. For the law of sines, we're going to look at the ratio. We're going to take the sine of 37, and its opposite side length is 11. And we're going to set that ratio equal to the sine of my angle B of 72 over little b, because we're solving for the side length. So let's take the cross multiplication of these. So b times the sine of 37 equals 11 sine of 72, and divide by the sine of 37. So b equals 11 times the sine of 72 divided by the sine of 37. So let's get out our calculators. Let's try and do this all on one. 11 times the sine of 72 divided by the sine of 37. Oops, I know that's not right. So let's check our mode. Now we'll get the right one. Oops. So 17.383. So let's go back to our directions, and it says round our answer to the nearest hundredth when necessary. So that's what we're going to do. 17.38. All right, we need to do a similar thing to solve for C. If we want to solve for C, we want to use our given ratio that we have, the sine of 37 over 11, and use C. Well, we don't have C in the picture, but we found it was 71. So the sine of 71 over little c, because that's our side length. Take the cross product. And divide by the sine of 37. So C equals 11 times the sine of 71 divided by the sine of 37. Oops, punched in the wrong answer. There we go, 17.28. And I obviously knew that that was wrong, because 71's got to be close to 72, so these two numbers should be pretty close to each other. So we've solved for the triangle. We're going to take a look at another example. So let's sketch out our triangle really quick. Put some labels on there. We've got A is 37 degrees, 12 minutes, and 23 seconds. B is 72 degrees, and little c is 11 So we've got a side angle side, or an angle side angle. Angle side angle. So right now we're thinking that we could possibly use the law of sines, but we don't have an angle over here to have a pair in order to solve for the missing side. So that's going to be our first thing. Solve for the measure of angle C, because once we solve for the measure of angle C, then we can figure out the ratios. So let's use our calculators and review how to use our calculators for degrees, minutes, and seconds. Triangle sum theorem, so I'm going to take from 180 degrees and subtract 72. I'm going to subtract 37 degrees, so we want to go second angle, get our degree. We need 12 minutes, so second angle, get the minute marker. And I want 23 seconds, and seconds is a double, so we want alpha, and it's right above a plus sign. And then press enter. Well, that gave us a great decimal. However, we want this to look a little bit different. I want it in minutes and degrees and the seconds, so I want to hit second angle, translate to degrees, minutes, seconds, and press enter. So 70 degrees, 47 minutes, and 37 seconds. So let's take a look at how we're going to solve for side A. Side A is going to be right here. So we're missing that, so I know the sine of 37 degrees, 12 minutes, and 23 seconds over side A is going to be equal to, well, the ratio that we do know is that C, and we found C, and we're going to use that right there. So the sine of 70 degrees, 47 minutes, and 37 seconds over 11. So we've got 11 times the sine of 37 degrees, 12 minutes, and 23 seconds is going to equal to A times the sine of 70 degrees, 47 minutes, and 37 seconds. So let's divide by the sine of 70 degrees, 47 minutes, and 37 seconds to get A by itself. And when we plug that all into our calculator, we get A is approximately, says to the nearest hundredth, so 7.04. We're going to do that same thing for B, except for B we get to use a little bit nicer of an angle. The sine of 72 over B equals, and then we're going to use the ratio that we were given. Well, the angle that we could find, 70 degrees, 47 minutes, and 37 seconds over 11. Take the cross product, divide by 70, so B is going to equal 11 times the sine of 72 over the sine of 70 degrees, 47 minutes, and 37 seconds. And when we plug that into our calculator and approximate to the nearest hundredth, we get 11.08. So this is where we're going to stop our first video. Please try that with your graphing calculator. If you have questions on that, make sure you post it on the Haiku page, and we will address them on the block day.